Assalamu alaikum. I hope you guys are doing well. So today we are bringing everything together. We have talked about the concepts of moles, we have talked about the formulas, we have talked about the ratio method, we have talked about how mole allows us to calculate everything about different reactants combining together in different ratios, different amounts, but we know how to predict volume, how to calculate the mass required, in fact, to predict the mass that we will get. Also, yield is a very important topic when it comes to industrial chemistry, because you are spending a lot of money, a lot of people are involved, a lot of good resources are involved in producing something like a fertilizer or a glass or whatever you're producing. Then you do want a better yield so that you get your money's worth, to be honest. And having a better yield always comes from understanding good chemistry, understanding how the reaction proceeds and how you can ensure the products that you'll get. Also, it is deeply associated, linked together with the finances of any production, of any reaction. So it saves a lot of money if you know what to expect and how to sell that to your clients or whatever you're using in industry. Mole is a very important topic for that as well. So today what we are going to do is we are going to go over last 3 years past paper questions for theory, and these are taken from O levels primarily, and we will see how the examiner has tried to approach the topic and how we can make sure that the mistakes that many students do, we don't do them. We identify what common themes are there and what kind of questions are asked so we can approach them with caution, but of course get the best results. Alright, so let's get started. Make sure that you have a periodic table with you. If you need, you can access the one in the official periodic table that is given to you. I've shared that in the WhatsApp group for rapid revision, so make sure that you join it. I'll share the link in the description. Also, you will need a calculator. You can use a regular scientific calculator, that will work, but if you use the one that has fractions, the ability to show fraction, they usually have natural display written at the top, or class whiz in some cases, the modern ones. So I would suggest that do get a calculator that shows fraction. It makes things much easier to work with. It reduces the error of approximation. You get the answer that you're expecting. So ECF is something that examiner might not need to use in your answers. We will not be going over the ATB questions today, but we will do that in some other session. Alright, so let's start with this one. Before we do, remember the formulas. Number of moles is mass over mR if you're using mass. For gases, it is volume divided by 24, because 1 mole is 24. And for formula for solution, it is N equal to CV. You also need to know the ratio method, because that really helps. I personally like ratio method better for, as you know, for personal reasons, because I kind of discovered it, that or so I thought back in grade 10. So let's get started with this. Calculate the maximum volume of hydrogen formed when 1.68 grams of magnesium reacts with excess dilute sulfuric acid. Now here's the thing. What they've said here is an excess dilute sulfuric acid. That word excess is super important, because what it basically translates to is ignore this thing. That's what it means. Ignore this substance, HCl. Right now you have more than you need, so just ignore this thing. Okay, so what does that make magnesium? The limiting reactant. Limiting reactant can be confusing if you approach it, because what it does is basically stop the reaction before it even completes. And the reason for that is that limiting reactant basically runs out. You use up all the thing that you have, and now you can't, the reaction cannot proceed. So in any reaction, it is always the limiting reactant that determines how much of the product is made. Again, I'm talking about reactions that go to completion. I'm not talking about reversible reactions where the reaction never goes to completion, and why, we will talk about that later on in a video. So over here we have magnesium as the limiting reactant. So whenever you identify the limiting reactant, always do calculations based on that one. Ignore the things that are in excess. All right. So over here we have magnesium in the limiting reactant. So we will use that. Make the equation. So magnesium reacts with HCl, producing magnesium chloride. The formula is MgCl2. You need to know how to write the formula. because remember the ratio flip method. If you need help, you can go to the video on formulas. Alright, then we have hydrogen gas being produced, and this you can balance it out by just putting a 2 here. Now it's balanced, we don't really need to put the state symbols at the moment. So let's get started with how much do we have, what do we have. So it says that we have 1.68 grams of magnesium, and we want to know what or how many dm cube of hydrogen that we get. Now this is a very interesting combination that the examiner has picked. They have picked magnesium which has an AR of 24, and they're asking us for volume of gas which is in dm cube, and 1 mole is always 24 dm cube. So the number 24 and 24 for hydrogen is the same, which means that just by looking at it I can say that the answer will be 1.68 dm cube. Alright, and that may be surprising, but it's not really, because 24 grams of magnesium makes 1 mole of hydrogen. So basically 1 mole of magnesium makes 1 mole of hydrogen. 1 mole of magnesium is 24 grams. 1 mole of hydrogen is 24 dm cube. So 24 grams of magnesium produces 24 dm cube of hydrogen. So why wouldn't 1.68 produce the same? It would, right? But let's show how we can show that to the examiner. So let's start with the formula method if you prefer that. So the formula method says that first find the moles of the first thing. So 1.68 grams, I'll divide that by AR, which is 24, and that will give me the number of moles of magnesium. When I do that, I get 0.07 as my number of moles. Now, because mole ratio is 1 to 1, 0.07 will produce 0.07. I can cross multiply if I want. So x equal to 0.07 moles. So this is the moles of hydrogen gas that I'll get. Now I will simply multiply this by 24, because number of moles is volume over 24. So volume is number of moles times the volume, and that will give me, well, you guessed it, it is 1.68. So yeah, 1.68 dm cube. Now let's say I don't want to use that. What other method do I have? I have the ratio method. What's the ratio method? Copy this thing, copy that thing. These are the two relevant bits here. So magnesium, 1 mole of magnesium makes 1 mole of hydrogen gas. So what is the mass of 1 mole? It is 24 grams. What is the volume of 1 mole? 24 dm cube. And 1.68 grams produces x. Cross multiply and x equal to 1.68. And it works. Exam में आप ये कर सकते हो. How convenient is that? Okay, so there you go. Alright, a hydrocarbon contains 88.9% carbon by mass. Now notice that they did not mention how much hydrogen that it has, but we don't need to know that because it is hydrocarbon. Hydrocarbons are the things that are made of only they're made of only hydrogen and carbon, and for that reason we just use that. Hello Ryan, hello Huda, yeah, good to see you here. And thank you. आपकी ही मेहनत है और आपकी ही contribution है. I hope I can help more students. Alright, so a hydrocarbon contains 8.9% carbon by mass. So basically it tells me that I have that much carbon, and the remaining part is of course hydrogen. So find the empirical formula. Now I told you that in empirical formula we just assume that I have 100 grams of this thing. So if I have 100 grams of this thing, how much of it will be carbon? Of course 88.9 grams. Alright, and how much will be hydrogen? Just subtract it from 100 and you'll get 11.1. So that is what you'll get. And now, so Ryan's question is, a ratio method is only if our given volume is mass, or we need to find mass volume, right? Actually, ratio method works for any moles question, and we will see today that it can be applied to any kind of question on moles. And ऐसे नहीं मैं खुश होता उस method पे. So there is a reason. Alright, so we divided by 12, we divided it by 1 because we want to figure out number of moles of this thing. Alright, so when we do that, 88.9 divided by 12, that is 7.41, and that is 11.1. Now I'll have to take the ratio, divide it by the smaller number to find the simplest ratio. When I do that, here I get 1, but over there I'm getting 1.5. Now, you might be inclined to just approximate that to 2, but don't do it. That's a fatal flaw. An examiner knows it. Basically, 1.5 converted to a fraction. So now I have 1 ratio 3 by 2. And just multiply by the LCM, 2. So it converts it to 2 ratio 3. And that's our answer, C2H3. That's my empirical formula. All right. You might be like, what fractions can I approximate? Actually, anything that is closer to like the next number or really close to the previous number, like 1.1 or 1.0 something or 1.9 something, you can approximate that. But for the rest, you should usually just approximate them. Convert them to fraction. For example, some fractions are easy to work with. This is a quarter, which is 0.25. This is a half, that is 0.5. This is a 3/4, that is 0.75. Similarly, if you have thirds, then 1/3 is 0.33 and it goes on, and 2/3 is 0.667 and all that. Now here's the thing, if I have 1.66 that continues to go on, I can just call it 1 whole 2 by 3 because this part is 2 by 3. So that converts it to a fraction right away. All right. So don't try to just approximate any number. If you can convert it to a fraction, use that, I would suggest. All right. So let's move on to this one. Dilute sulfuric acid reacts with sodium hydroxide. Okay. The equation is given, it's balanced, I don't need to do it. In IGCSE, they usually give you equation which is incomplete or that needs balancing. So always do that before you actually do a reaction. But if your balancing is wrong, the answer that you do, you will not lose marks because of the balancing. If any ratio method is going wrong because your equation is not balanced correctly, that's perfectly fine. You will just lose, it's not exactly fine, but you will lose marks for balancing, not for the moles question. Alright, so a student adds 0.76 grams of solid sodium hydroxide. So this is 0.76 grams. Just note that down once you get that information. To 45 cm cube, that's the volume, of 0.2 mole per dm cube. I usually approximate that as a capital M because that can be written as mole per dm cube. Alright, so this is my data. I'm going to work with this data. Show by calculation that the sodium hydroxide is in excess. Now, what exactly does that mean? This thing can be interpreted in saying that show that sodium hydroxide is in excess or show that sulfuric acid is limiting reactant. So what do you do in this case? Basically, whatever you want to show as limiting reactant, don't use that information. Okay? Don't use that information. Use the one for the excess one. I'll show you how to do it. So for example, I know that 1 mole, so first of all, whenever you have a solution, I've told you that find the number of moles of that thing. So solution of sulfuric acid is N equal to Cv, that is C 0.2, V is 45 over 1000. So I'll do that, and I'll get 45 over 1000 times 2, that is 0.09. So that's the number of moles I have, okay? So I have the number of moles. Now, I'm going to show that sulfuric acid is in limiting quantity, which will imply that sodium hydroxide is in excess. Okay. What do I have of sodium hydroxide? I have mass. So just find the mass of sodium hydroxide, Mr. So Mr of sodium hydroxide is 23 plus 16 plus 1, that is 40. Okay, so what does it tell me? 1 mole of H2SO4 reacts with 2 moles of NaOH. So that is 2 times 40. Okay. So how much would 0.09 react with? X, cross multiply. This is the ratio method. I'm using the ratio method. So that gives me 0.09 times 2 times 40. That is 7.2 grams. I think I made a mistake in calculation somewhere. Oh yeah, this one should be 0.09, which will make this one 0.72. So you have 0.76. You need 0.72. So that shows that because 0.72 is less than 0.76, sodium hydroxide is in excess. There you go. Now let's say you don't like that method. I want to use some other method. Sure, no problem. Let's do that. Again, N equal to Cv has to stay. All right, let's try to figure out this same thing, but by figuring out how much sulfuric acid I need. Okay, so what is my moles of sodium hydroxide? I can do it through formula method, or I can do it otherwise. So 1 mole of sodium hydroxide, 1 mole of sulfuric acid reacts with 2 moles, which is 40 grams, 2 times 40 grams. So this is the mass of sodium hydroxide, and this is the moles of sulfuric acid. You might ask, why am I not using just moles of sodium hydroxide? Because I've been given the mass. Or why am I not using some other thing of sulfuric acid? Because it's a solution. For solutions, you only use moles. All right. How much mass do you have? You have 0.76. So how much will it need? So let's do cross multiplication. X times 2 times 40 equal to 0.76 times 1. So x equal to 0.76 over 2 times 40. That is 0.76 divided by 2 times 40. So that is 0.095. How much do you have? 0.095 is more than 0.09. You have less than you need, right? You have less sulfuric acid than you need to completely react with 0.76 grams of sodium hydroxide. So this is limiting. So H2SO4 is limiting. So that implies sodium hydroxide is in excess. You have to mention that. Just don't say sulfuric acid is limiting. It doesn't automatically imply the other thing is in excess. Clarify it. All right. Give the examiner full information. वो आप पे बात ना कर सके कि आपने पूरी बात नहीं की. Right? So you can do that. What if you want to use formulas? You don't like this. Sure. We can still do it. So the method doesn't really matter. What matters is, are you getting the right answer? Do you understand what the process is? And hopefully today you will. All right, so let's get started with this. 0.09 moles of sulfuric acid. I have that. How much sodium hydroxide do I need? So 0.1 mole reacts with 2 moles. So 0.09 will react with X moles. X comes out to be 0.018 moles of sodium hydroxide. What is the mass of that thing? So mass is number of moles times MR. So 0.018 times MR, which is 40. That gives me, we just calculated it a bit ago, 0.72. Okay, so 0.72 is less than 0.76. So sodium hydroxide is in excess. We've shown it. Okay, so write that. Okay, moving on. So just a closing note on limiting reactant. You have to calculate how much of that thing you need. That's very important. You will not use the information that's given. For example, if you notice, I only used mass of sodium hydroxide at the very end. Or when I was using sulfuric acid, I used the information at the very end over there. You have to, whether you want to show it as a limiting reactant or you want to show it as an excess, you have to use that information at the end. बाकी सारी चीज़ों की information use करें. But whatever you want to show as a limiting quantity or as an excess, उसकी information आप end पे use करेंगे कि देखें, over here I had 0.76 for sodium hydroxide, so I didn't touch that. I first calculated how much sodium hydroxide do I need, and then when I got the value 0.72, I said that is less than what I have, so it is in excess. So that is a hint for you. जिसको भी आपने in excess show कराना है उसकी value आपने end पे use करनी है. जिसको आपने limiting use करना है उसकी value आपने end पे use करनी है. That's the last step. Alright? And that is why students get confused कि शुरू कहाँ से करना है. तो अब आपको पता है end कहाँ पे करना है. तो automatically दूसरी चीज़ की information से आप start करेंगे. Alright? So that's how you will do this one. Okay. Moving on. An oxide of phosphorus has the formula P4O10. Calculate the percentage by mass of phosphorus. It's a really straightforward question. I need to figure out the MR first. So MR of P4O10 is 4 times P is 31 plus 16 times 10. So that is 124 plus 160. That is 284. Let me confirm. Yeah, that's 284. So that's my mass of 1 mole. Now, how much of that was coming from phosphorus? The advantage you have if you do it like that, if you show all the steps, is that you don't have to recalculate how much phosphorus I need. I already know that that is 124. So I'll just take 124 divided by 284, multiply by 100% to find my percentage by mass. So that is percentage by mass of phosphorus. I find it easier to write the left side of the equation, although that carries no marks. But when I'm reviewing my answers, it really tells me that, oh, this is what I did. And then it makes sense to me after I'm done with the paper. So I would suggest you try to do something like that as well. So 124 divided by 284, that is going to be 0.437%. And no, sorry, that is 43.7%. And that's my answer. All right, moving on. Calculate the minimum mass of calcium carbonate in grams, so they've told you the unit, needed to produce 16.8 cm cube of carbon dioxide at room temperature and pressure. Okay, so again, write the equation first. You have calcium carbonate breaks down, you know the decomposition. So calcium carbonate breaks down to produce calcium oxide and carbon dioxide. By the way, IGCSE people have known it for a few years, but O-levels people just got this thing added to their syllabus. You have to know how nitrates and carbonates of group 2 break down. So this is the equation for group 2 metals, oxide, metal carbonates. What happens is that you're left with metal oxide. For example, in this case, you have calcium oxide. So if this was a barium carbonate, it will be barium oxide. That's what you'll be left with. Similarly, for the nitrate one, you need to know the equation. So here's the standard equation that you can obviously alter based on what you need. So if I had calcium nitrate and I try to break it down. Now in O-levels or IGCSE, you don't need to know which one breaks first or which one breaks later. You don't need to know that. Hello Zen, good to see you here. But you need to know that they do break down and they produce calcium oxide in this case, plus nitrogen dioxide, plus oxygen. And you can balance it by putting this. And by the way, fractions are acceptable for balancing equations. Assalamualaikum Abdullah, good to see you here. Yeah, so it is important that you know that in carbonates, carbon dioxide is produced, nitrates when they break down, nitrogen dioxide and oxygen is produced. Of course, the metal oxide depends on what metal you have. If you had barium, it will be barium oxide. It will be, if it was something else, it will be that metal. Thank you, Zan. All right, so I have this information and I need to remember this. So coming back to my equation here, my question here. My question said that I have calcium carbonate breaking down, producing carbon dioxide. The mole ratio is 1:1, so that makes things really easy. All right, so what information do I have? I want to produce 16.8 grams of carbon dioxide using this. So I'll just write that 16.8 cm cube of this. And I want to find mass of this thing. All right, I'll use the ratio method. So 100 grams, 100 is the MR of calcium carbonate, produces 1 mole, which is 24 dm cube. So that is 24,000 dm cube, right? It's 24,000 cm cube, sorry. Cross multiply, and you'll know this is 16.8 times 100 divided by 24,000. That is 0.07 grams. That's how much calcium carbonate you need to break it down. Now, what if you don't want to use this method? You want to use the traditional method of using formulas. Do we still get 0.07? Of course we will, but let's show. So again, the traditional method is a 3-step method. And here's what you do. You start with the number of moles of the first thing. You start with whatever information they've given. Whatever info you have, you start with that. Then you find the number of moles of the first thing. For example, in this case, they've told us about carbon dioxide. So I'll use the number of moles of that. Then I've used mole ratio to figure out number of moles of the second thing. In this case, calcium carbonate. And then I get my answer. So that is the approach that you should have if you use formulas or if you use this traditional method of solving questions. Again, this is a perfectly good method and you can use it. And whatever makes sense to you that's the important thing, because the examiner is not going to award you marks for a method, but doing the right method and for getting the right answers. That's important. So let's start with this. I have 16.8 cm cube of carbon dioxide, so I'll divide it by 24,000 or divided by 1,000 and then divided by 24. It's the same thing. To find number of moles of carbon dioxide. That is 7 into 10 power minus 4. It's fine to write it as standard form. All right. Then mole ratio, 1 mole produces 1, so 7 into 10 power minus 4 will produce 7 into 10 power minus 4. All right, so number of moles of calcium carbonate is the same. Now I find mass. Mass is number of moles time mr. Fortunately, in this case, I have mr as straight 100. So multiply by 100 and you get 0.07 grams. There you go. All right. Hydrated sodium iodate 5. Now, why is this telling it? Again, this is something new for us. In O levels, we're used to using old names, archaic names. This is an IUPAC name. IUPAC is the organization that names chemicals. In fact, yeah, like there is actually a organization that names different chemicals. So the reason it's saying 5 is because the oxidation state or oxidation number of iodide is 5 in this case. Iodate ion, as you can see over here, is this one. You don't need to remember this, but you should be familiar with molecular ions. For example, you might have seen chlorate or you might have seen nitrate, right? So nitrate is NO3, just like that iodate is IO3, all right? So chlorate would be ClO3, all right? And the reason it's saying 5 is because the oxidation number of iodine is 5. Now, this is not charged. Don't confuse it with charge. With metals, for example, if I said iron 3 chloride, then over there, this thing is charge of iron ion, or it also can be interpreted as oxidation numbers. But for non-metals, it's not the charge. It is their oxidation number, which is slightly different from charge. So charge can be oxidation number, but oxidation number doesn't always have to be charge. But what is it or why, how to find it and all that is not really required at the time. So don't worry about that. Just know that iodate 5 means it is iodine's molecular ion with oxygen and the oxidation number is 5. On an unrelated note, can you guess what kind of bonding sodium iodate 5 will have? If you know, just write it in chat. This is interesting. Because, okay, I'll wait for a couple of minutes more. Yeah, so basically this is, yes, Ryan, you're right. It has ionic bonding in it because you have sodium ions, you have iodate 5 ions. But iodate 5 is a molecular ion. It is an ion made from iodide and oxygen, and it has covalent bonding in it. So this compound, sodium iodate, has both ionic and covalent bond. In fact, any molecular ion that you get, like sulfate or nitrate or chlorate, they all have covalent bonding in them. Ammonium has covalent bonding in them. But when they bond with some other ion, they form ionic bond. So in the MCQs, they can ask you that which compound has both covalent and metallic, covalent and ionic. So your answer should be 1 for molecular ions. All right. Acids are an exception because acids, for example, acids have H2SO4, for example, it forms hydrogen ion and sulfate ion, but only when you dissolve it in water, right? When it's not in water, H2SO4 is covalent completely because it is all non-metals. So acids, when they're not dissolved in water, they have covalent bonding only. And that is one reason hydrogen is not put into the metal category. It has many properties that are similar to metals, but it's not entirely metal in the periodic table, as you can see. Anyway, so let's come back to the question. It is saying it has the formula mass of 288. This is a really easy question because you just need to figure out the formula mass. What is formula mass? For ionic compounds, we don't say molecular mass, we say formula mass, but it's still MR. That's how it's written. So MR does not mean molecular mass, it means relative mass. For molecules, it will be relative molecular mass, and for ionic component will be relative formula mass. So Mr is 288. Let me just add everything up. So I have 1 sodium, 1 iodine, 3 oxygen, X water. Okay, so I'll just plug in the numbers here. So sodium is 23, iodine, I'll have to check, I think it's 127. Let me see. Yeah, it is 127. 3 times 16 for oxygen plus 18 times X, 288. Okay, so we just add everything up on this side and subtract it from that side. Okay, so 23 plus 127 is 150 plus 48 is 198. So subtract it from 288. That's 190 or just 90? Just 90. Let me confirm. 90. So X is 5. Yeah. So X is 5. So what is it telling me? It's telling me that 5 moles of water are attached to sodium iodide. Now, what do we call this water? You might remember this is called water of crystallization. And secondly, how do you get rid of it? Just heat to constant mass. Heat to constant mass. In fact, in experimental techniques, if they ask you to make pure dry sample, then you have to use this expression that you're heating to constant mass. How do you do it in the lab? You heat that thing, wait, then you heat it again, then wait, and once the mass stops changing, you take that thing. Of course, you can't take things that are breaking down. You have to be careful that you don't heat them to the extent that the thing itself starts to break down. For example, iodine, we don't want it to break down. In the case of nitrate, as we just saw, they do break down and they undergo thermal decomposition. So you have to make sure that you don't go over the limit. All right. Next question. The equation for the reaction of butanoic acid with sodium carbonate is shown. Okay. A student adds 5.28 grams of butanoic acid. Again, they've given us this information. 256 cm3 or 0.5 mole per dm cube sodium carbonate. Show that by calculation butanoic acid. This is similar to the question that we just did. So I'm going to give you a few minutes. Try to attempt it yourself and then we'll see if we get the right answer. So you should be able to do it by now. Let's see. Again, you want to show that butanoic acid is in excess, right? So don't use this information until the very end. That's your hint. All right. Okay. So let's begin. How do we do this? First, figure out how much mass of butanoic acid you actually need. So I have number of moles of the other thing. Sorry. So that is going to be 0.5 N equal to Cv, right? Into 56 over 1000. So that is going to be 0.028 moles of sodium carbonate. That's what I have, sodium carbonate. Now mole ratio is 2 to 1. So 0.028 will produce X. X will come out to be 0.056 moles. And this is butanoic acid. You can use ratios here. Yes, Ryan. I'll show you how to use ratios in this case. And then we have what is the MR of this thing? So I'll have to calculate the MR to figure out the mass. So it's going to be 3 times 12 plus 8 times, sorry, it's 4 times 12. There's 4 carbons, butanoic. And then 8 times hydrogen, which is 1 plus 2 times 16. So that is 48 plus 56 plus 32, 88. That's the MR. Okay, so now I'll multiply moles with MR. So 88 times 0.056 will give me the mass. So 88 times 0.056, that is 4.928. That is less than 5.28. So clearly it is in excess. And let's suppose you don't want to use this. You want to use ratios. So how would you do it? Now, because these are, one of these is solution, you have to find number of moles. In solutions, you can only compare number of moles. So we already have that, so I'll reuse that. So I have C3H7COOH on one side and sodium carbonate on the other side. Okay. Now let's look at the moles. 2 moles of this reacts with 1 mole of that. Okay. What is the mass of 2 moles? It is 2 times 88. Okay, so this is basically telling me that 2 times 88 grams of this thing will react with 1 mole of the other thing. Okay. How many moles do I have? 0.028. So how much mass will I need? X. Cross multiply. So X will be 0.028 times 2 times 88. Okay. So that is going to be actually exactly the same. 4.928. That is less than 5.28. So it's in excess. Again, ratio method or the other method doesn't matter. What matters is doing it right, having your concepts clear. Okay, let's move on. Okay. Titanium is a metallic element. Titanium is made by reducing TiCl4 using magnesium. They've used this word reducing. If you watch my recording from yesterday, we talk about reduction and oxidation quite a lot of detail, or how it is tested in the exam. Also, there's a very important angle that you need to understand here, that magnesium is more reactive than titanium. We all know that. But why is that? That is because magnesium, you can also interpret the same thing as saying magnesium loses electrons faster than titanium. So magnesium is a better, stronger reducing agent than titanium. So over here, magnesium is the reducing agent. All right, so all metals are reducing agents, by the way. Let's see. We want to figure out mass of titanium made from 1000 grams of TiCl4. I have 1000 grams of this and I want to find mass of titanium. They're both masses, so it's going to be a pretty straightforward question. But it says it has a 90% yield. Okay, so we will use the yield at the end. Use purity in the beginning, yield at the end. Alright, so here's what we should do. First of all, let me figure out the MR of titanium 4 chloride. So titanium has an AR, let me check, 204. Okay, so if I use the ratio method, relative atomic mass of titanium is 48. Oh, sorry, I was using thallium. Yeah, it is 48. It's pretty straightforward. Number 22 element in the periodic table. Okay, so what's the MR of TiCl4? 48 plus 4 times 35.5. Use the AR value, not the value you might remember, like 35 nahi use karna. Okay, so this is 190. What is the mole ratio telling me? 190 grams of this thing produces 1 mole, which is 48 grams of titanium. So 1000 grams should produce X. X will come out to be cross multiply 48 into 1000 divided by 190. So 48,000 divided by 190 is 252.6. My percentage yield is 0.9 or 90%. So my actual mass that I'll get is 90% of this. So 0.9 or 90% of 252.6 gives me 227 grams. 3 significant figures is good enough. Let's suppose you don't want to use this method, you want to use the formula method. So that's again pretty straightforward. Yes, Ryan, that is the correct interpretation. It needs to spend the least amount of energy between titanium and magnesium. Magnesium spends least energy to lose that electron. Losing electron, yeah. All right. In fact, magnesium has to lose 2 electrons, and titanium in this case gained 4 electrons. So that could also be a factor. Anyways, if I want to use the ratio, if I don't want to use the ratio method, I want to use the other method, then what I'll do is I'll first figure out, again, remember this shape, you start with the info that you have, you find the number of moles of the first thing, number of moles of the other thing, and then you find the answer. All right. Okay, so how do we do this? I have 1000 grams of TiCl4, so I'll start by figuring out the number of moles of TiCl4. That is 1000 grams divided by mR, which is 190. I calculated just now. So that gives me 5.26. That's the number of moles of TiCl4. I will use the mole ratio. Mole ratio is 1:1, so I will get the same moles of titanium, and mass of that will be number of moles times AR. So 5.26 times 48. So that is going to be 252.6. Now here's what I did. Although I wrote 5.26, I did not change the value on the calculator. I just let it be. And I use that value in the next step because it will make sure that my answer is still accurate even if I've approximated over there. 90% of this, that is 90%, times 252.6, and that's 227. I have my answer. Okay, going good so far. If you have any questions, feel free to put them in chat, or you can also WhatsApp me. All right, let's do this question. Ammonium iodide is a white solid which decomposes when heated. This is there. Ammonium ion, we already know, breaks down into ammonia and H positive, and that is why ammonium salts are acidic when they react. Calculate the volume of gas measured formed when 2.9 gram of ammonium iodide is completely decomposed. We have 2.9 grams of this thing, and we want to figure out moles of volume of this thing. Again, such a simple question. They couldn't have made. Do you follow a pattern here? Like in any question, this is exactly what they're doing. Moles isn't as scary as we think it is. There's just a pattern to this, and we just need to understand what to apply and where. So if you need to brush up on your concept, just go to the previous videos from Monday and Tuesday, and you will see. I think the date was 14th and 15th Feb. All right, so this is again a pretty straightforward question. I will figure out the MR. So if I want to use the usual method, yeah, we always use the percentage yield at the end. Yes, always calculate it at the end. So traditional method is find MR of ammonium iodide first. So that is going to be 127 for iodine, 4 for hydrogen, and 14 for hydrogen. That's why it's 4. So 127 plus 18, that is 145. That's the MR of ammonium iodide. So the number of moles of ammonium iodide that I have is 2.9 divided by 145. 2.9 divided by that is 0.02. That's a neat number. And then 0.02 mole ratio 1:1. So 0.02 is the moles of iodine that I get, ammonia that I get. So volume is moles multiplied by 24. That's going to be 0.48 dm cube. Straightforward. Now, if I wanted to use the ratio method, again, I have ammonium iodide on one side, ammonia on the other side, but ammonia I'm going to use volume. Ammonium iodide has 145 grams, 1 mole, produces 1 mole ammonia, which is 24 dm cube. I have 2.9 grams. It produces x dm cube. Cross multiply. Every time I do this, I get happy because of the method. Okay, 0.48. There you go. And yeah, that brings us to the end of this session. This worksheet still has 6 more pages of questions from past papers, the last 3 years. I will share the worksheet in the WhatsApp group. If you need to join the WhatsApp group, I'll put the link in the description, and feel free to ask any questions, send any questions, and I will try to make sure that you get your answers. And yeah, good luck. Thank you.